Okay, this video is about organising data using tables, so it means getting data into tables. I'm going to take a few shortcuts over what I was originally going to do. Here you'll notice this is the number of people per residence or per house in a street. And you can tell that we have 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we must be talking about 40 houses. Now, the lowest number that's mentioned in here is 1. And the highest, we've got a 7 here. So that's lowest, and 7 looks to be the highest. So the number of people goes 1, 2, 3, 4, 5, 6, 7. And if you were to do this like the way that I suggested in the previous video, you would work down each column. So you'd do 4 at a time. So you'd go 1, 1, 1, 3, 7. That's that one done. And then 7, 2, 4, 1, etc. I'll just put etc. And you'd get a frequency here of 9, 11, 6, 6, 4, 2, 2. And when you add that up, I'll do some really cryptic maths here. 9 and 11 is 20, 6 and 4 is 10, 6 and the 2 2s is 4 is another 10, so that's 20, 30, 40, so that adds up to 40. Okay, so moving on to the next one. This time, if you look at the data, we seem to have data ranging from 7 up to 12 point something. This data here is about returns in superannuation funds. So this is a percentage, and it looks as if the lowest is 7. And it looks as if the highest is 12 point something. We have a 12.2. We have a 12.1. It looks like 12.2 is the highest. So we need to set this out to get reflect that. And we need to follow the rules of grouping. We need to have groups here because from 7.0 to 12.2 there's a difference of, if you go to one decimal place anyway, of about 5.2, which if you allowed one line in your table for each 0.1 is 52 lines, and that's too many. So we need to group. And if we just go 7, 8, 9, 10, 11, 12, that's probably not enough groups. So I'm going to suggest for grouping that we go from 7 but less than 7.5. And then 7.5 but less than 8. I would argue that this is a continuous variable because the return could go on for many decimal places, but it's just convenience that it's been rounded to one decimal place. But keeping on going here, so 7 up to but less than 8.5, and then 8.5 up to less than 9. Okay, so what that means is that 9 is not included, but anything that's just a smidge below is. So then 9 up to but less than 9.5, and then 9.5 up to less than 10, and then we go from 10 up to but less than 10.5, and then we go from 10.5 up to but less than 11, and then we go from 11 up to but less than 11.5, and then 11.5 up to but less than 12, and then from 12 up to but less than 12.5. Okay, and now we have to get that data entered, and this time we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers in the table that way and 4 that way. 8 4s are 32. So we should get a total of 32 when we've finished. This time I'd argue we should go across. So 9.6 belongs in this group. So we put a tally mark. 7 is the lowest. It just goes in the bottom of that group. 8.9 is in this group, and 9.1 would be in this group. Do the next row. We've done that row. 8.9 is in that group. 9.7 will be in that group. 10.1 will be in that group, and 7.4 will be in that group. Alright, in the module it mentions some rules for setting up groups. They should have the same width. That means, if you subtract the highest for each group from the lowest, you should end up with the same number. What else? You need to make sure that any value can be included, so you shouldn't have breaks. It should be clear where a number belongs. So 7.5 would belong in this group. It would not belong in this group because it says less than 7.5. Okay, so 7.5 belongs in this group. Anyway, I'm not going to fill in the rest of that. I'm just going to write in the frequencies because I did this earlier. And if you wanted to, you could complete this and just double check it. And when you add all of those up, you do get 32. That's your double check, remember. Okay, with the next one, we've been asked to organise our data, our superannuation fund data, into a stem and leaf. So what we need to do is have a look at this and look at the numbers and the range. So once again, it goes from 7 up to 12.2. And think about what we could make stems and leaves, etc. And it looks as if the whole number part could be a stem. So 7, 8, 9, 10, 11, 12. And the decimal part then becomes a leaf. So for example, if we had 8, and this line here is like this bar here, 8 bar 3 means 8.3. And that's important, and it's 8.3% return, because that gives us the size of our values, because it could be 83, it could be 830, or it could be a whole lot of other things. But if you just put that there, you know that between the stem and the leaf you end up with something point something. Okay, so this one's quite awkward to do, because I can fill this out. Yeah, I'll fill this out, and then what we really want is an ordered stem and leaf, because when you do this from your data into your table, it's originally unordered. So, okay, 9.6. So this is the 9 sort of row. So we put a 6 here, and that would be 9.6. That's what our legend, our key tells us here. 7.0 means a 0 there. 8.9 means a 9 there, and 9.1 means a 1 there. So we've done one row. 7.0, it is important that you put the 0 in. 8.9 means you put a 9 here. 9.7, 10.1, 7.4. Now you'll notice that I'm spacing these out. When I finish, this is going to look like a histogram on its side, and you'll be able to see where most of the data is sort of centred. So 10.7 is a 7, 9.6 is a 6, 9.2, 9.3, that's that row. 11.8, 9.9, 10.3, 8.9, that's that row. 8.7, 12.2, 7.1, 9.5. 8.9, 8.0, 10.5, 7.8, 9.2, 7.3, 10.7, 12.1, 8.4, 9.7, 11.4, 11.7. Now, as I mentioned before, the problem with this is it's an unordered stem and leaf plot, and we prefer that it's ordered. So what I'll do here is I'll simply rub out each lot and re-put them in order. So I happen to have a paper copy, which makes this quite easy for me to do. In practice, you may need to do a whole new table. Okay, so that's organised the data. Beauty with a stem and leaf is that the original values are retained, and that's really positive, and the way that we've ordered each of the leaves, the data is now ordered. We have the lowest value sitting up here, and we have the highest value sitting here. So that's a stem and leaf chart.